Good morning, everybody. I was already introduced by the colleague. I want to mention that we prepared this presentation together with Davide, and we will share this stage. For the people in the audience that doesn't know Reply Group is a company founded in Italy 30 years ago. As you can see in the graphic here, the results that we have reached in those years speaks for themselves. We have reached more than 2.5 billion revenues in the last year, and we have now more than 16,000 employees around the world, located in 38 states. You can see here the map. What Reply does, we are a system integrator. Previous slide. We are a system integrators focused in the most innovative areas in the market in the moment in which we operate. Our daily work is done from researches, from lab work, in order to provide to our customers the best of breed solution, and in order to make them distinctive and future-proofed. The words that you see here obviously all speaks about innovation, digital human, co-pilots, workplaces, immersive experience, AI, networks, cybersecurity, and so on and so forth. Exactly due to this innovation-driven DNA of Reply and obviously our reliability in the market, we are one of the direct partners of IPCI's project. I'm very proud to be here. So, what will Reply provide for this project, which we think is a very, very important one for the different reasons that were discussed during those two days in this stage. We aim to realize and to enable macro use cases that are cross industries and cross different markets. Just to provide some examples here, we have intelligent user interaction and communications, which is just a big trend going on, and we expect it to grow faster in the future. Then dynamic autonomous task allocation strategies for multiple robot systems in cloud edge. I know it's a huge topic, but Davide will explain it later on this talk. And simulation and training of autonomous vehicles in edge cloud. Here comes the change. How we can realize those macro use cases that goes across different technological layers, different industries, different markets. It was challenging and still is. And I hope that this, graphical representation can provide a better explanatory, view for all of you. In the bottom part, we use the network resources. We are not a telco. I will not be a telco anyway, but we use those network resources and the metrics from the network in our second layer, so in the mid layer, which is the orchestration domain. The orchestration domain has inside different layers that are used for specific operations, and can allocate resources and deploy applications in the best edge site available. Best edge site available, it's important as concept, because what we mean by edge site, all edge sites that are federated with our platform can be federated already, or that will be federated in the future, and can be Reply edge sites or partner edge sites. And this is an important topic. I want to stress a little bit the point. The top layer, as we can see here in the picture, is the application layers. With that layer, we manage and handle robotics, fleets, drones, controller, or autonomous guided vehicles, and everything that is in the upper side of the application. The whole solution is AI native, as we are using different training models, different AI agents, different algorithms in order to automate the tasks and the decisions within the platform. With this being said, Davide, you can come, please. I want to say some other items where we are now, because it will be maybe a question from the audience. The current status is that we have already built the end-to-end skeleton through the through the three technological layers. We have integrated and already tested as end-to-end our main features, and currently we are integrating our solution with different partners, IPCI partners and external partners, just to mention some of those integrations that are already ongoing, not finished, but ongoing, with the team, with Telefonica, with T-Systems. Yesterday we were discussing with the colleagues from Open Nebula, Cabit, which is an SME external of IPCI, ARSIS, and so on. So my aim would be that please contact us, because we would like to share and collaborate and to provide our platform capabilities to your solutions, and vice versa. I'll hand over to Davide. Thank you.
Thank you, Gentiana, for the kind introduction. I'm Davide Vilella, and today I'll be presenting one of our major use case, which is multi-robot fleet. Let's begin with a general overview of the workflow of our solution. The user can interact with the system with AI agent, so it's possible to request deployment of application using natural language. The request is sent to our multi-domain orchestrator, where it goes through a different layer of orchestration. And in this process, there are multiple AI agents involved doing specific tasks, such as selecting the best edge site for application deployment and translating the request into a deployment intent. For this use case we are presenting today, the user requests the deployment of our collaboration platform, which is used for managing a robotic fleet. And it has two layers. The first is autonomous core layer, which is used for IoT application deployment, and the second is autonomous vehicle collaboration layer, which enables for managing of robotic fleet. It's important to say that edge site selected may be different from the one where the user or the autonomous vehicle are located. It can be whatever edge site connected to our orchestrator. Let's now delve more in detail in the autonomous vehicle collaboration layer. That, as said before, it's enabled for the management of devices and multi-robotic heterogeneous fleet. User can interact with the system through a dedicated dashboard, and from here it's possible to check all the system information, such as device battery charge, the list of all the device connected, and the list of all the completed and scheduled tasks. For user, it's possible to schedule new task or dispatch new task from a dedicated form, in which it's necessary to insert the type of task required and list of places to visit for completing the job. Then there is a second way, which is much easier, that is through an AI agent. So user can specify in natural language what he needs and when. The agent will translate and extract all the tasks required for completing the job, and then the platform will handle all the necessary coordination and execution step. One major feature of our system is the possibility of integration for any device from any manufacturer, thus giving the user the possibility and the freedom of choosing what are the tools that better suits for their scenario. This kind of approach brings three benefits, such as the elimination of vendor lock-in, as can be integrated vehicles and robots from any vendors. It enhances deployment facilities, as it's possible to add or remove robot with ease without re-engineering the entire system. And it also enhances the value of the robotic asset of the various company, as it is possible to integrate their existing fleet and extending vehicle life cycle and extending the range, thus reducing cost. Let's now better analyze the case when collaboration between two or more robots is required. In this kind of situation, rather than relying on direct robot-to-robot communication, which can be fragile, our system adopts a centralized management. So it's the system that sends each robot the right command at the right time, ensuring that each robot receives precise information. And this is critical in scenarios when dealing with robots with different capabilities or different communication protocol. This kind of centralized architecture can bring let's move on. We were talking about collaboration between multiple devices with different capabilities. So with this kind of architecture, with the centralized management, we simplify integration and reduce system complexity. As for operator and development and developer, don't have worries about compatibility issue. And furthermore, it's possible to they don't have to interact with custom interfaces, as they just have one single collaboration platform that ensures consistent behavior across all heterogeneous fleet. Furthermore, we enhance reliability and dynamic response. In fact, as a matter of fact, our system can detect any problem or unexpected behavior from the device connected and trigger dynamically a recovery action based on user preferences. This is crucial in a real-time environment where faults can bring to operational delays. So let's summarize what we presented today and focus on the takeaway from our presentation. So our solution provides scalability, as it easily adapts to different operational scales, from small deployment to large and complex environment. It's portable, as application and orchestration logic can be deployed on various hardware and software platforms. We offer a flexible deployment option, as application can be deployed either locally on the cloud edge. Is a vendor-agnostic solution, as every robot and device from any manufacturer can be integrated in the system, ensuring flexibility and the possibility of choosing the best tool for the job. We offer also a real-time information exchange, as our system, our platform, manage data flow and communication between devices in real time, enabling fast and coordinated response. And we also offer a centralized and customizable error handling system, as in case of fault, the trigger recovery action can be tailored to specific situation and be customized from the user. So thank you for your attention. This is our contact. Feel free to contact us and ask for any question. We are here to respond.
Thank you very much. Do we have some questions for Davide and Gentiana? Not questions going in one, questions going in. Oh, we have.
You have a centralized solution. Isn't
Yes.
that a single point of failure? So.
No, it's not. It's not a single point of failure, as our solution is deployed on Kubernetes cluster. So we have multiple pods across different devices. So our solution is not centralized. As I said before, it can be deployed on various edge sites in the same moment. So we have multiple instances of our application on multiple devices, and we offer flexibility and we can adapt to various situations. So if one device fall down for any reasons, the traffic will be transferred to the available devices connected.
Thank you. Gentiana would like to add something, or is answered? It's answered. We have more questions.
I share somehow the same concern, but the reason why you are following the centralized approach is because you don't trust the capacity of the single robots to work autonomously, let's say. It's just an intermediate step. Do you have any plan for the future to give more responsibilities to the single robots?
Well, actually, the system collect every robot and device connected their capabilities. So the system knows which robot and device can do what. So if the system receive a request for doing one specific job, it autonomously handle the job to the robot and devices that can do that required task. So actually the system knows what the robot can do, and it chooses the better option for that specific request at that specific time. It's just that the multiple device don't know what other device can do. So the system knows everything, but the device don't know what other can do, and the communication is with the system. Is the system that manages communication between device if they're collaborating.
Thank you. Do we have one more question? Okay, I would like once again to thank Davide and Gentiana for the presentation.
Thank
Please,
you all for
a round of
your attention.
applause.